Hello guys, and welcome back to the Flying Math channel. Today I want to show you another Drak. This is actually the third Drak that I've built. I've built two previous ones for a friend, and this is going to be my own, which I intend to use for mapping purposes. So what I want to show you today is I'll show you some footage on the maiden flight of this aircraft, and then I'll also go over the way that I installed the Pixhawk system. So hopefully for those of you who intend to use this aircraft as a mapper, it will be useful information for you guys. Some things that I want to say about this now that I've had some time on this airframe is that it really is a good platform for the purpose of mapping. And the reason I say that is it's one of those aircraft that does not have a roll reaction when there is a change in the oncoming wind direction over the wing. So when you have gusty wind conditions, the plane does not react by rolling. In most aircraft of conventional design, because they have a degree of dihedral in the wing, that V shape, if you have a change in the oncoming wind direction as you get with gusty conditions, then very often the reaction of the aircraft will be to roll in response. So you don't see this with this aircraft, which is a big advantage for mapping. Another thing that I like about it is that it can fly fast and slow without having to change the trim. So again, something that leads to is when you have gusty conditions, you don't see a lot of pitch change in the aircraft. It tends to be more stable under gusty wind conditions. Other things that I like about this is it has gobs and gobs of space, for installation of electronics. So it's very easy to install your electronic components. You can use it with a wide range of cameras. In fact, I'm going to use in this plane, I'm going to use a Sony Alpha 5100, and that camera can very easily be placed transversely into the fuselage, very close to the CG, which is an advantage. When you can place the camera transversely, then it increases the efficiency of mapping. So overall, I just think this is a great airframe for mapping. It's also, of course, made of EPP, which is a material that is very, very resilient. So it is not as prone to dings and scratches and so on as most other materials are. It has a very strong shape memory. So you can press into this material very hard and it will just bounce back and retain the exact same shape that it started with. So as far as that's concerned, it's also a major advantage because this plane will probably get used a lot in rough conditions, with lots of rough landings within tall vegetation and so on. So with that, I think let's get into the details of the Pixhawk installation. Okay, so let's start with the main bay. And as I mentioned, a luxury in this plane is that you have so much space. So you can spread things out. You don't have to scratch your head too much about where you need to put things. You have so many options. So as far as that is concerned, it's a real pleasure to work on this plane. So open the front cover there as well. So of course that's where the battery goes, and the camera in this plane will go right in front of the main spar. So that will be just about on top of the CG, which is an advantage because when you want to use different cameras, different weights, you don't have to worry about the CG changing as you change out payloads. Okay, so let's get back to the main bay here. So in the center there, fairly close to the center of gravity and in the center of the plane laterally, is the Pixhawk. And then to the right hand side there you can see the power module for the Pixhawk, which of course delivers power to the Pixhawk itself. So it's redundant power. It also gets power from the 5-volt power supply here. Here is the buzzer. So again, just so much space, you can just spread things out any way you like almost. There is the I2C expansion board, and then I chose to place my GPS here, on the saddle. It's a nice and convenient area, and it's not obstructed, by anything. So it's easy to catch satellites that way. And then also another consideration for putting it there is it gives you some space between the high voltage wiring and the magnetometer that's associated with the GPS. So I tested that. This seems to be a good position without any magnetic interferences from the high voltage wires. And then the placement of the Pixhawk camera shutter release is there because it allows me to, let me just close the lid here, because it has a little LED on top of the unit. So right on top of the unit there is a blue LED that flashes when the camera triggers. So that flash of light is easily visible through the crack between the two lids. And basically what that allows me to do is to easily basically just see that the camera triggering is working before takeoff. Let's go on to the left bay. So this is where I have my receiver. I'm using a FreeSky receiver with a Taranis radio on this aircraft. And then this is one area where I kind of scratch my head a little bit, because I didn't have enough length for the of cabling for the speed sensor unit, combined with the length of the tubing that I had. So the amount of leeway that I had in terms of placing the pitot tube in the nose was not enough, without having had to potentially extend the wiring quite considerably. So I decided to rather go and place the pitot tube on the left wing. Now, one of my concerns is that possibly there could be some turbulence coming from the nose that might affect the pitot tube. So that's something that I'll have to test, and I'll let you know how that works out. But I think I've got enough distance here for that to hopefully not be a serious issue. So the other thing that I want to point out here is I use Velcro to attach the pitot tube, and that's important to me because I tend to fly planes when I do mapping in areas where I don't have a good runway surface. So when I land in rough vegetation, the pitot tube is often something that can get hung up. So this way, if it gets a hard bump, it will just sort of pop off. Other thing I want to point out here is this is where the external LED light is for the Pixhawk. So I just made a tiny hole in the bottom here of the coroplast, and then the LED sits right up against the outer shell of the coroplast here, and it actually shines the light through this red coroplast very easily. If you have black coroplast instead of red, you may have to cut a hole or something else to allow the light to shine through, so that you can assess the colors, the communication colors that the Pixhawk provides. So this seems to work very well. On the other side, this is where I have my arming switch for the Pixhawk, and maybe I could just show you how I do that. So these are the tools that I need to do that. So my main channels I use this tool with, to basically just I heat this up with a butane torch, and then I poke the hole right through, and then I heat this the sponge up with a butane torch as well, and just use that to make a vertical hole, and then you push the arming switch through that. So very quick and easy, works like a charm. Then on this side, I've got the telemetry radio. So the telemetry radio, I don't know if I'm going to leave it in that spot, but for a start, I thought I would just put it there and see how it works, and I'll probably put it in a more secure position later on, in a more permanent position. But I first want to test it out, in this position without having to cut any holes or anything in the bays. So probably, I will move that back and place it on the surface, bottom surface of the bay later on, and then make a hole for the antenna to poke through. Okay, so that's basically it. Maybe just one small thing to point out as well. So I use servo wire extensions to go from the Pixhawk to the wire that attaches to the servo. So if you take the wings off, then you can just basically break this connection here and pull the wings out, and when you put the wing back on again, the same thing. So I kind of designed the setup so that I only have to open the side bays to prepare the aircraft. I don't have to open the main bay, which is secured by 4 thumb screws, so it's a bit of a pain in the butt to have to open that up all the time. So when I assemble the plane, I'll just have to open up the side bays, and of course I have access to the main bay for installation of the camera and the battery. Okay, so that was the overview of the Pixhawk installation in the Drak. The next step is going to be to test the Drak with the Pixhawk installed and work on the tuning parameters, the PID tuning parameters. So once I've got that figured out, and once I'm happy with the way it flies, then the next step will be to install the camera and do an actual mapping mission. So hopefully the next video that you will see on this aircraft will be where I can demonstrate how to set up a mapping mission, do the execution of it, and we can look at the results. And also I can share with you what I came up with as far as the tuning parameters for the Pixhawk is concerned. So stay tuned for that, and thanks for watching. Thanks for staying with me so long. I know this is a fairly long video, and hopefully I'll see you in the not too distant future with the follow-up of a mapping mission with the Ritewing Drak. See you then.